Okay, so hello everyone, welcome. Can you hear me? Hello. Okay, can you hear me?
Yes, sir, you are audible.
Okay, thank you. Okay, so just we are waiting some 1 or 2 minutes for joining all of those other participants. Then we'll start. So in the meantime, I also give you an announcement for our upcoming online training program. Mainly, this online training program will be start from that 12th January. So now this registration is the open, and first 10 registered people will get the 50% discount. So here already admitted total 6 people. So now only 4 seats are available for this 50% discount. So if you want to join this online training program with 50% discount, so as soon as possible, you can simply complete your registration. For completing your registration, you can simply contact in this WhatsApp number and also contact with this email. Then you can easily make the registration. So basically, this online training program, you are learn all of those things from beginners to advanced level on Google Earth Engine, and we are start from the stress level and up to the advanced level of Google Earth Engine platform. We try to complete all of those things. So I hope if you have no knowledge about the Google Earth Engine, or if you have no knowledge about the Python or JavaScript, so this course is for you. So because in this online training program, we teach you all of those programming languages also. Okay, and I already add all of this information in the video description. I hope you can either check it, and then further if you want to join, then simply contact. So in this online training program, you also get some benefits, such as you can get the course certificate, you can get all of the slide PDF, you can get all of those practice code, then recorded video class, and you also get the lifetime teaching support. So basically, when you want to learn Google Earth Engine platform, in the first of all, you face a lot of problem. So that's why you need the continuous support. So for getting this support, you can get the lifetime teaching support regarding this training program. So that's why I hope you can easily smoothly learn all of those things and apply in your research. So if you want to join, simply contact in this WhatsApp number, also contact with this email. I already add all of this information in the video description. Simply check and then join. Thank you. Okay, so hello everyone, welcome. So basically today is our sixth number class, and today we try to discuss about that machine learning method, how we can easily apply with Google Earth Engine, and then try to make the land use land cover classification. Okay, so this type of things we try to complete. So let's go. Just I simply share my screen. So now can you see my screen? Okay, so now can you see my screen? Okay, so let's go. So mainly today's session, I will try to discuss about this topic, introduction to machine learning in Google Earth Engine, then how to make land use land cover mapping using machine learning. Mainly we try to discuss about the supervised and unsupervised. And for the supervised, we try to discuss about that random forest, hard, support vector machine, minimum distance classifier, how to use, and then make the land use land cover classification map. After making the land use land cover classification map, we also try to discuss about the accuracy assessment using the Google Earth Engine platform. So mainly overall accuracy, kappa accuracy, producer accuracy, consumer accuracy, how we can easily calculate. we try to discuss about that. Then calculate the land use land cover classes area. Then how we can easily add the legend in our map using the Google Earth Engine platform, we try to discuss. And finally, we can easily export this land use land cover map and make a proper map using the ArcMap software. Okay, so let's go. Just a simple open my slide. So machine learning in Art Engine. So basically in Art Engine platform, we can easily apply the machine learning such as supervised, unsupervised, and regression. We can easily do. So mainly supervised classification. When you want to do, you must need the ground truth data, or you need the level or pre-categorized data when you want to make the supervised classification. And mainly unsupervised classification, you don't need any types of ground truth data, or you don't need any types of training sample or pre-categorized data. Don't need. Okay. And regression, mainly it's the classification model attempts to the bucket is input into a discrete classes, and it also mainly used for the different types of prediction or water quality predict, as well as percent forest cover, present cloud cover of the crop yield. So this type of things need the. So in this time, I talk about the two things, supervised and unsupervised. So mainly when you want to make the supervised, we must need the ground truth data, or we also need about the training sample. Okay. And unsupervised, we don't need any types of ground truth data. So basically two classification method we learn and also try to implement and make the land use land cover classification map using Google Earth Engine platform. So now, first of all, what is classifier? So mainly the algorithm which implement the classification on a data set is known as a classifier. Suppose in this time I use here the random forest algorithm, such as cart algorithm or support vector machine algorithm. So this type of algorithm is also known as a classifier. Suppose random forest classifier, classification regression trees classifier, support vector machine classifier. Okay. And mainly we are get the two types of classification, mainly binary classifier and multi-class classifier. So binary classifier, mainly from that we can get the possible two possible outcome. Okay, such as suppose yes or no, male or female, stem or not stem, cat or dog. Only two class. It's called the binary class. And multi-class, when you want to make the more than two outcome. Okay, when you can get the more than two outcome, so it's called as a multi-class classifier, such as land use, land cover classification, suppose types of crop classification, types of music. So this type of mainly it's a multi-class classifier we need to use. So in this time, we talk about that how we can easily make the land use, land cover classification map. Okay. Suppose mainly first of all, we talk about that supervised, then talk about the unsupervised. So what's the process when you want to make the land use, land cover classification map using Google Earth Engine platform? So first of all, you just need to selecting your region of interest. Which region you want to make the land use land cover classification map? You can simply select your region of interest. After that, you are just choosing and filtering the image collection. Okay. Suppose which image you want to choose. If you want, you can use here the Lancet, or if you want, you can also use here the Sentinel. Simply choose and then filter this image collection for your study area, for your specific time period, as well as also a specific cloud coverage. So this type of things you can simply filter. After, you need to collecting the training point, because in this time we are applying the supervised. Supervised, for that you need to collect the training sample or training point for each classes. Suppose you want to make the land use land cover classification map for build up area, water body, vegetation, agricultural land, parent land. So for that, all of those class, you need to collect the training sample. And how we can easily get the training sample? So basically, in this time, we are applying the different types of band combination. Okay. So we are using the different types of band combination, and then we collect the training sample from the satellite images. So I'll show you the practical after some time. And then we need to merge all of those training point. Suppose all of the sample or all of the training point, I simply merge and store it in a variable. And then we need to make a training data set. In this time, mainly this data set, suppose you just simply choose some specific band suppose red, green, blue, near infrared, short wave infrared. So this type of band you select, and this all which point you merge. So this type of point extract the pixel value from this band and make a data set. Okay, suppose I just simply select some band. This all of those bands, from all of those training point, extract the band pixel value for a spectrum signature for each point or each classes. It extract and make a data set. So mainly this data set, when you can create, we are just use a function sample region. So this sample region function need to use and then create a training data set. So in the machine learning model, this data set we need to split. Suppose you are just using the 80% data to train your model and 20% data you use for check your validation or test your model. So after creating the training data set, we just split the data set into two ways. One is the 80% data, suppose train your model, and 20% data for test your model, or 70% data for train your model, or 30% data for test your model. You can simply split this data set. And further, you are just create the classifier. Okay, so you can simply create the classifier. In this time, we would already know about the classifier. So mainly classifier is the which algorithm you want to use. Suppose I use here the random forest algorithm. So suppose I create the random forest classifier and train my 80% data, which I already split, and then classify the image. And further create the classified image and then display the result. And then in this time, rest of the 20% data, in this time, I just compare my result with that and create the confusion matrix or error matrix. So further, when I can get the confusion matrix table, from the confusion matrix table, I can easily calculate the all of those accuracies, such as overall accuracy, producer accuracy, consumer accuracy, kappa accuracy. We can easily calculate. Okay. So after creating all of those things, then we talk about that how we can easily calculate the area for each classes, such as what's the area for the wildlife area, forest, or agricultural land, how much area is available for the we try to discuss. So in this time, okay, so practically I show you all of those things one by one. So just I simply open a new code editor. So first of all, I need to import my ROI or region of interest, which area you want to make the land use land cover classification. Suppose in this time, I just simply import a region of interest. Suppose I simply import the, suppose Dhaka city, I simply import. And you can see it will be imported. A default name is the table. I simply change it. I give a name, suppose ROI. Okay. So now, suppose I try to display the layer of this shape file. So just I use here the map dot add layer function and add a layer of ROI and click to run. And I also need to focus the center of the shape file. Use here the map dot center object. Object is that ROI. Put the zoom level, suppose 10. Click to the run. So now I got my study area. So this is my study area. I want to make the land use land cover classification map for this study area. So my first step is done. Okay. So now talk about the second step. In this time, we talk about the second step. In the second step, we need to choose and filtering the image collection. If you want, you can use here the Lancet, or if you want, you can use here the Sentinel. No problem. When you want to use here the Sentinel, we can get the better land use land cover classification map, because Sentinel is the 10-meter resolution or 12-meter resolution, but Lancet is the 30-meter. Okay, so Lancet Sentinel is better than Lancet for land use, but Sentinel it start from the year of 2015, but Lancet we can start from that year of 1973. Okay, so when you want to make the historical land use land cover change detection, then you must use here the Lancet. But for the present time, suppose 2023 or year of 2015 to present time, we can easily use here the Sentinel-2 satellite imagery. Okay, so in this time I want to show you that how we can easily use here the Sentinel-2. But same process you can also apply for the Lancet, no problem. I simply land use land cover classification map. Okay, so here you can see two types of images you can get from here. In this time, we need to use the surface reflectance, this satellite image. Basically, surface reflectance satellite image is better for make the land use land cover classification. Okay. So now in this time here you can see this time availability time period, we can get the dataset provider, artisan snippet, okay, as well as all of those band we can get from here. Okay. In this time, first of all, you need to simply copy this artisan snippet from here and then paste in here. Suppose I simply take a variable, suppose image, and paste it. Okay. So now my image collection is imported in my code editor. So now you can simply filter. Okay. We already know about the how we can easily filter. Okay. So we already discussed about that. So you can simply put here the filter bounds function and filter bounds with your study area ROI, as well as you are just use a function, suppose filter date function. Suppose I want to make the map for year of 2023 1st January from year of 2023 December, suppose 31. Okay. Or what is the recent time period, you can check about that. You can see 28. Okay. So I simply put it the 28, December 28. And then I'll just put here this, suppose filter metadata, and put here this image properties. So in this time, I want to put here the cloud pixel percentage less than 1. Simply copy this and then paste here, and then use at that less than 1. Okay. So in this time, if you want to check how many images I want to got according this condition, just simply use at the print and call this image and use at the size function. So now it determine how many images is available for this condition, less than 1% cloud cover, and this time period. We can get the 29 images is available. Okay. So in this time, when you want to work with a single date image, it also possible. Or if you want, you can just make the median composite using total 29 images and make a composite. So I just make the median composite. So just use here the median, and then finally use clip with my study area, which is RY. So now display this result, but that's simply use here map dot add layer and call this image and click the run. So now it visualize a median composite for year of 2023, January to December 28. So let's check the image. Okay, we can get this type of image. So further, I simply add the visualization. Click on here, and I'm going to add here the visualization. Suppose red, green, and blue, and apply, and custom 98%, and then apply.
Uh, Excuse me, sir.
Yeah, please.
So sometimes when we stretch, the range changes, and sometimes it's also change. Why it happens?
Okay, so basically in this time, it depends on this pixel range. Suppose in this time, when I stretch this image, mainly it increase the pixel value. Okay, suppose in this time, first of all, it shows as a 0. Suppose custom. Okay, custom mainly, you can see when I put here the custom, we can get the same, no problem. But when I stretch 98%, okay, so we already make the 98%. That's it. Suppose I put here the 100%. In this time we can get this type of things. Only integer value. You can see only integer. There is not any types of double or float is not available. Okay. Suppose I put here the 98%. You can see now it also considered about that. Also integer value. Okay. And this value you can see this value is not accurate value. Okay. Suppose this basically it's identify about that pixel value. Suppose a pixel value b4 b3 b2, this combination make this type of pixel value, but it show very high. Okay, so for that in this time you can see this image is also provide another information, this information, the scale information, and you can see all of those bands are the same scale. Okay, so when I rescaling it, then we are also get the proper value. Okay, suppose I simply copy that, but it's not mandatory. But when you want to get the proper pixel value about that, So thus you can simply use a function, suppose multiply, and then paste and click the run. So now in this time you can see when I just click the stress, then we can get the actual value of the is band. Okay, so in this time after multiply these things, this all of those band for this sentinel-2, it get the proper scaling. Suppose I just simply click on here, and then suppose 98%. So now you can see we can get the this proper pixel value, minimum 0.035 and maximum 0.148. This is the range about that proper pixel with this band combination. So just simply apply. Okay, so now we can get, and I'll check about the suppose red and green. We set the red, green, and blue. I click on here again and put here that red, green, and blue. Custom 98% stress. Now apply. Okay. So now we can get the proper pixel about that. Further it show about the very long value 400 or 600. But when I multiply this scale, all of those band, so now we can get the proper scale value of each band. And when I make the data set, then we also check about the proper scale value, such as this range will be maintained. Suppose not show about the 400, 500, 600. Okay, when you not multiply these things, it also correct, but in this time it display the proper scale value, okay, or proper pixel value for each band, because I multiply with my scale, and all of those
So
band is the
when
same
we
scale.
need to,
Which one?
yeah. So I'm saying when we need to find the NDVI, then we also have to do the same thing for the proper values.
Not only for all images. Oh yeah, for the proper values, for the only for the sentinel. So basically, this type of scale you can check. First of all, you try to check about your data set. If there is the available for the scale, then you must use it. Suppose mode is mainly Lancet is not okay. Lancet is also available for the scale and offset value. Okay. So basically, when you want to get this type of information, scale or offset, try to add. Then I hope you can get the better pixel value about that. Otherwise, it not show the better pixel value. Okay. Same when you want to
Okay.
make the NDVI or NDWI or anything. Okay. Get the proper image. Just try to multiply. So in this time, you can see it's this is the scale. So just simply multiply the scale. Sometimes you will also get for the Lancet offset value. Suppose yeah, another column show about the offset value. So multiply this scale and add with offset. Okay, which we show you that for that LST monitoring. Okay, for the LST monitoring, I'll show you that you put a scale value and then multiply the scale value and add with the offset. So this is the formula about that. Then when you want to multiply the scale and add with offset, then we are get the proper pixel value. Then it also more better. Yeah. Okay. So now we can get the image. So just I simply import and then simply copy this visualization from here and paste after the object name. So object name. So my second step is done. So mainly I collect the image. I just make the image. Okay. So now we talk about the third step. Third step mainly in this time, we are just need to collect some training sample because it's a supervised classification. Third step, we need to collect the training point. When you can get this image, after that we just simply take the training point for each classes. And training point mainly it's depend on your accuracy. Suppose if you did not get the better accuracy, then you also need to increasing the training sample. Okay, so I'll show you the further how we can easily increase the accuracy. Okay, so first of all, more than 30 for each classes, I take the training sample and then make the classification. And if I don't get the better accuracy, then I also need to increasing the training sample or decreasing the training sample. Okay, so first of all, I try to make the algorithm more than 30 points for each classes. Okay, So in this time, this you can see in this time I use here the red, green, and blue band. Okay, then I can get this type of band combination. It's mainly true color composite. Okay, so in this time, from here I can easily identify this type of feature. You can see it is the water body. I can easily identify, as well as I can identify it's a build up area. Okay, as well as I can easily identify it's a vegetation. Okay, you can see vegetation. I can easily identify. Then it's a barren land. Okay, but not only for this band combination. If you want, you can also use here the more other types of band combination. Suppose I just simply show you another band combination. So mainly it's the near infrared band. So I simply put here the near infrared, mainly B8 for sentinel, then red band, and put here that uh, green band. Stress 98%, and then apply. So now we can get the another band combination. In this band combination, we get the water body as a dark color. Okay, you can see it's a black color or dark color. We can get water body, and vegetation show as a red color. Okay, so this type of red color identify about the vegetation. Okay, in this time, suppose I want to add another band combination. Suppose I just use that short wave infrared, then near infrared B8, and use here the suppose blue, and then state 98%, and further apply. So in this time, it also helpful to identify for that vegetation, cropland. We can identify barren land. Okay, in this time, this type of gray color. In this time, you can see this type of green color identify about the vegetation. Okay, green color identify about the vegetation, and also you can see when I zoom it. This type of gray color identify about the barren land. Okay, you can see the barren land, and this type of color in this time you can see we can get it's also barren land, but it also considered as a wetland. Okay, so as you can see this type of it's only for the barren land, and this type of color identify about the wetland about that, and we can easily identify this type of things is the vegetation. Okay, you can green identify the vegetation, and it's a water body. We already know about that, and so basically, not only for that, there are a lot of band combination. Okay, suppose you want to make the land use land cover classification map for any unknown region, which region you did not visit physically. So for that, you have to use the different types of band combination and try to find out the feature on the surface, and then collect the training sample. Okay, so not only for that, a lot of band combination includes use. Okay, you can also search on the Google about the band combination, then you try to easily you can easily add the any band combination in here. Okay, for 3 band you can simply select and make the any band combination. Okay, so now I want to collect the training sample. So how I can collect the training sample? Very easy, just click on the marker, and marker, if you want, you can also use at the polygon or rectangle, but this polygon and rectangle, it mainly when you want to use, mainly it chance to exist the limit of the pixel. Okay, then it will not load it. So that's why point is better to use for collecting the training sample. But suppose I take the polygon, I just take the big polygon about the water body, then there are a lot of pixel, and it's also some limitation about that. It when it exists the limit about the 5,000 pixel value, then it not work. So that's why we are just take the marker, it's better, and then click on the properties. I put the label. Suppose I put the label is that water. Okay, and then feature collection, and add the property. I simply put the property. You can put any name. I just simply put the name, suppose class, and set the value for water, suppose 0. Okay, then okay. So now we can easily identify it's a water body. Just you can simply collect some training sample from this water body.
So what is training sample basically in lame language?
Okay, training sample mainly in this time it's a machine learning, so that's why it's a supervised machine learning model. Supervised machine learning model, we need the training point or training sample. Mainly this training sample, it's help you to train your model. Okay, suppose in this time what happened? Suppose I just click on here. So in this time, each point, suppose here I get total 22 points. Okay, so 22 points extract the pixel value. Suppose I just make a all of those band. I just make a band. Suppose all of those bands. Suppose you can see here already available B1, B2, B3, B4. All of those band is available. Suppose I select all of those band and each point. Suppose each point collect all of those band pixel value. Okay, for water body, as well as when I collect the training sample for the vegetation, all of those points extract the band pixel value for the vegetation. Suppose when I collect the training sample for the build up area, then all of those training sample or training point extract the band pixel value for the build up area and create a data set. Okay, so then this data set, when I apply on the machine learning such as random forest, then it easily classified. This pixel is water, this pixel is vegetation, this pixel for barren land, this pixel for agricultural land, anything. So in this time, we need the point. Suppose in this time, I just simply collect some point for each classes. Okay. So further, this each point extract the band pixel value and make a data set. Okay. So then this data set I need to train with my model. And how I create the model, in this time we are just using the random forest. So further, I show you that how we can easily create the model. So in this time, we are just collecting the training point. So further, all of those training point extract the band pixel value or spectral signature for each classes. So further, we are just use it and train our model and make the classification. Suppose I take this training point for the water. Okay. Then suppose I take the training point for that vegetation. Just click on here, new layer, click on here again. Suppose I just put here that vegetation.
So we don't need to cover the whole body, we just need few samples.
Few samples, not for the whole, and whole body covered by machine predict. Okay,
So
suppose
what
in
is
this time I take here that water body only for this region. Okay, but when I make the machine learning algorithm, it automatically predict all of those same pixel for water body on the image and identify it's a water body. Okay, but I just take the training sample only from here. But when this similar pixel is also available for this water, because all of those objects on the surface have a unique spectra. Okay, any object, it can be vegetation, it can be water body, it can be agricultural land. This object has unique. Suppose water pixel value and vegetation pixel value is not same. Water pixel value, barren land pixel value is not same. Water pixel value and build up pixel value is not same. So that's why this machine learning easily predict for the other region and classify. This is the water body, this is the vegetation, this is the build up area, this is the agricultural land, anyone. Okay. So in this time, we just take the training sample or training point for each class which you want to classify. Okay. Feature collection, same. Set the property. Suppose class. Put here the suppose 1. First of all, you can see I just put here the 0 for water, then vegetation for 1. So now select the vegetation layer and just take the some training sample for the vegetation. Suppose it's a vegetation, I simply select.
Sir, is there any minimum value of points,
No,
like we have to
no.
collect like this much
Basically,
of points?
you try to use at the more than 30 and further check the accuracy. If I did not get the better accuracy, then I also need to increase my training sample. Okay, suppose I can get the very, very low accuracy, 60%, suppose 70%. I need the more better accuracy, then you need to increase the training sample or training point. So first of all, in this time, we try to suppose 41. If I did not get the better accuracy, then I also need to increase that. Okay, suppose I get the very low accuracy, then I also increase the training sample. Okay, so in this time you can see I just take the training sample only for this region, but other region is also available. In this time I don't take, because machine learning is automatically predict. This type of vegetation is automatically predict. Okay, because this pixel, this vegetation pixel, and other types of vegetation pixel is all same. This spectra is the same. So for that, machine is automatically predict it also vegetation and show the result as the vegetation. Okay. So now I take the another class, suppose parallel, and set the import as feature collection and set the property. Mainly property is that same all time class and put at the 2. Okay. So I just simply take this training sample for the barren land. So it's a barren land. Suppose sometimes any mistake. Suppose I simply put on the vegetation. Okay, it's let the barren land, but I put the vegetation. So for that, simply click on the exit and then click on here, and you can see the delete option. Click the delete. Okay, then take it again. Suppose click on here, select the barren land, and then simply collect the training sample. Then this time we are just considering the barren and wetland at a same class. But if you want, you can also differentiate. Then you have to take the 2 time a training sample. One time is for the barren land, another time for only for the barren land, wetland. In this time, we'll just keep in one class. Okay, done. So for that, I take this training sample for suppose build up. So just simply take the new layer and just take the geometry as a build up. Imported feature collection. Property, same property, just put here the class. And set the value for 3. So basically you can see first 0, then 1, then 2, then 3. Okay. And in this time I want to use here the suppose true color composite, because true color composite is the better view of the build up area. So it's red and put at the green, put at the blue. Yes, 98%. And apply. So now I simply take this training sample build up area. So select the build up area and select the marker. Okay. So just simply take this training sample. Okay, so I take this training sample build up. So now in this time, after collecting the training point, our third step is done. Okay. So in this time, our fourth step. Fourth step, mainly in this time, we need to merge all of those training sample, need to merge and store it in a one variable. Okay. Any question, please? Yeah, please. Okay, so it's not basically this question is that in this time you try to build up your model up to 30 training sample first time. Okay, when you face any, suppose you get the very low accuracy, then you also try to increase your training point, but minimum requirement is the 30 or 50 or 40. No problem. First of all, you train your model and then check your accuracy. Okay, then suppose you did not get the better accuracy, then you are just increasing your training sample, then it also okay, no problem. Okay. Okay. So in this time, I just simply take a variable, suppose sample, and in this variable I just stored all of those training sample. Suppose first of all water, it merge with vegetation. It also merge with, I simply merge all of those training sample together. Barland, it merge with build up. Okay, so in this time, all of those training sample I merged and stored it in a variable samples. So just I simply print. So print these samples, click the run. In this time, mainly these samples create the pre-categorized data or label. So in this time, it create the label. How much we can create the label? 183. So in this time, all of this total training point is that 183. And I set the level for each point. So if you want to check it, suppose what is the level for the this point, click on here, you can check about the level. This level is that 0. Okay, so for this training point I use for the water. Okay, you can see all of those training point have a level. Suppose 40, I check it, you can see class 1. So for this training point I take for that vegetation. Okay, so it's a label. So it is the main condition for the supervised machine learning model. First of all, you need to make the training sample, or you need to create the pre-categorized data or label data. So in this time I create my label. Suppose all of this training sample, I just make the label as a point. So you can see all of this training sample have a label. So you can see the label. So this training point I want to use for the one. So what is the one? One mainly vegetation. So this training sample extract the information for vegetation. Okay. So in this time, I need to create a data set. Okay, using this sample I need to create the dataset. Dataset mainly extract the band pixel value or create the your mainly spectral signature. Okay, so for that I just take a variable, suppose bands. I make a list which band I want to use. In this time here you can see already available this type of band. So in this time, I just consider only for the 10 meter and 20 meter. Okay. 60 meter don't need. In this time, I simply consider 10 meter and 20 meter band. So mainly B2, B3, B4, B5, B6, B7, B8, B8A, then B11 and B12. Okay, so I just used only for the 10 meter and 20 meter bands for my create the spectral signature. So for that, let's go. I put here that B2, B3, B4, B5, B6, B7, B8, B8A, then B11 and B12. Just put here the B11 and B12. Now I just extract the band pixel value of each classes. So all of those training points. Suppose this training point extract all of those band pixel value. All of those this training point extract all of this band pixel value. So total 183 training points extract the all of those band pixel value and make a data set. So further we are just use this data set and train our model. Okay, so let's go how we can easily make the data set. So in this time, our fifth step is that create the data set. Okay. So data set mainly spectral signature of each classes. Just take a variable. Suppose I put the training. And in this time, I simply call my image. So this is my image. I simply copy and paste here. Okay. So further, I just call select, mainly select all of those band because I want to extract the band pixel value only for this band and paste. And then use a function, mainly this function called the sample regions, and put all of those argument. Okay, So just I make a dictionary. So for that curly bracket start and also curly bracket in. So first of all, collection. Collection mainly your training sample. In this time, my collection is the 183, which is stored in this variable. Simply copy and paste. Then properties. In this time, properties is mainly which you put in here. You can see property name, class, same name we just put in here for the properties. And this properties, it's a plural form. So for that, we have to use here square bracket and put here this. Okay. Then scale. Scale is that we are just put here the scale for that suppose 10 meter, and it's not. I simply remove that. It's not need. In this time, I just simply print that. So just print this training. Now it create the data set, and this data set mainly struck all of those pixel value. Suppose is point struck the all of those pixel value which is set in here. In this time here you can see it create the data set. So here you can see this is the data set. So click on here. Here you can see the feature. So mainly in this time is point. Suppose this is the point. This point struck the total 11th bands value. You can see B11, B12, all of those pixel value stored. You can see. And what is the level? Level for 0. Okay. So is point struck the all of those band pixel value. Is point. And it's my data set. Okay. So you can see all of those pixel. So is single point, all of those point struck the band pixel value. And it's my spectral signature or data set. So further, this data set I want to use and train my model and also test my model. Okay. So in this time, this data set I need to split into 80% and 20%. So let's go. After creating the data set, we need to split data set into two ways. Suppose 80% I just use for train, and rest of the 20% I just use for test. Okay. So in this time and do these things, we are just do these things mainly randomly. Okay. Suppose we do this 80% and 20% data randomly. So for that, I just take a variable. Suppose I put the variable name is that data set, and this my training. It is stored a full data set. I simply copy and paste here, and I do these things randomly. So that's why I simply put a function random column. Okay. So this function mainly randomly distributed this data set and stored it in this variable. So further, I just separate the data set 80% and 20%. So for that, I just put here separate the 80%. So just take a variable, suppose train set, and call my full data set. This data set is simply filtered. So just use here the filter. I want to filter Earth Engine filter greater than random 0.8. And if you want to print that, suppose I simply print the train set and click run. So in this time, it just only, you can see it considers the 45. Okay. So this 45, suppose in this time, this type of data. So this type of data I want to use for train my model, 80% data. Okay. And then rest of this data I want to use for test my data or algorithm. So for that, I just take another variable, suppose test set, and call my full data set and filter Earth Engine filter less than equal random 0.8. So now simply print that. So print test set and click run. We can get this type of data 138. Okay, so this type of data I want to use for check my accuracy. Okay, so in this time, for that in this time, so after split this data set, we are just make a algorithm or classifier. So for this classifier, in this time, suppose I just make the classifier, and classifier mainly it's identify about your algorithm, which algorithm you want to use for your classification, and you can easily find out all of those algorithm under the docs tab. Suppose click on here, and it's a totally ready-made algorithm, so that's why we did not need to change anything. So in this time here you can see the lot of algorithm, such as you can see regression tree, also you can see support vector machine, also new algorithm, you can see load, minimum distance, part algorithm. Okay, also you can see that a lot of algorithm you can easily use here. So in this time I want to use here the random forest. So just simply click on here, and random forest here you can see some argument such as number of trees. Basically this number of trees it very important, because for the number of trees it also need for check get the better accuracy. Okay, so what's the number of trees we have to, what's the best number of trees we need to mention in here. It's not a fixed, we have to calculate this value number of trees and find out the best number of trees for my algorithm. Okay, so I'll show you the process how we can easily calculate the number of trees. So I simply copy that and then paste. So in this time, this is my algorithm, and this algorithm, okay, in this time I just need only for the number of trees. So in this time I don't know what's the best number of trees for my model. I don't know. In this time I simply put it the 150, and this number is not fixed. Okay, so I want to put the 150 and then check my accuracy, what the accuracy I can got when I put here the 150, what the accuracy I can got. But it has the another way to calculate the number of best number of trees, and this best number of trees it's called the hyperparameter tuning. Okay, so mainly this, when you want to find out your best number of trees, it's called the hyperparameter tuning, and this hyperparameter tuning help you to improve your machine learning model accuracy. Okay, so we also try to discuss a lot of things for the next class, how you can easily find out the hyperparameter tuning and improve the accuracy. So in this time I randomly put here the 150. Okay, but it's not fixed. Okay, after that I just take a variable, take a function train, and then put all of those things and make a dictionary. So curly bracket start and curly bracket int.